Hello bachcho, so let's see the question. A coil of area 100 centimeter square has 500 turns. Magnetic field of 0.1 Weber per meter square is perpendicular to the coil. The field is reduced to 0 in zero point 0.1 second. The induced EMF in the coil is, first option is 1 volt, second option is 5 volt, third option is 50 volt, and the fourth option is 0. So let's see the given data as we have. Area is given as 100 centimeter square. Now convert it into the meters. So 100 into 10 to the power minus 4, you will get the value of 10 to the power minus 2 meter square. Number of turns is given as 500. Also the magnetic field of 0.1 Weber per meter square. So you have the initial magnetic field as 0.1 Weber per meter square, and the magnetic field is placed perpendicular to the coil. Okay, so the magnetic field is perpendicular to the coil. So we have, suppose this is coil, so magnetic field will be like this. Okay, so this is perpendicular to the coil, so it is along the area vector as well. So magnetic field and area both are in the same direction. So initially the angle between magnetic field and area comes out to be 0. Okay, the field is now reducing to the 0, so the B final goes out to be how much? 0. Then in the time interval of 0.1 second, the time interval of 0.1 second. Now you have to calculate the induced EMF in the coil. Here in this question you can use the concept of Lenz's law. And what the Lenz's law says? Nothing but it just gives the direction. Okay, so just Lenz's law gives the direction of the induced EMF and simply state that it will oppose the change in flux due to which it is induced, right? So equals to minus delta phi by delta t. So induced EMF can be written as minus of N into A delta B by delta T. Since there is only change in magnetic field, number of turns and area will remain the same. Okay, so delta phi is equals to N A to delta B, right? So just put the values. Minus of 500, area is 10 to the power minus 2, delta B is how much? Let's see the value of delta B. Delta B, how much comes out to be? 0.1 minus of 0.1, right? 0 minus 0.1 upon time interval is of 0.1 seconds, right? Solving it further, minus of 5, 10 to the power 2, so 10 to the power minus 2 get cancelled out, into minus of 0.1 upon 0.1. Minus to minus get cancelled out, and 0.21 to 0.1. So you will get the final answer as 5 volts. So the induced EMF in this question is 5 volts, which is your B option. So B option is the right answer. Okay, you got the concept. Okay, all the very best.